Hello everyone, welcome to the 14th part for the playlist in which we are discussing about the job interview questions for civil engineers and exam questions and the helpful material for site engineers. So this is the 14th part, and in today's video we are going to discuss few more important points. And okay, let's go to the first point. And for today's discussion, the first point is the number of bricks required for 1 meter cube. We got 1 meter cube of brick masonry, right? And we need they are saying that there will be 500 bricks. Let's check it out and solve it out. As we know that there are two terms. One is standard bricks, right? Standard brick size, and other is modular brick size. We need to know the difference between these two terms, standard and modular. The standard size of brick is, we know that 19 centimeters by 9 centimeters by 9 centimeters. Is that right? Modular size is 20 centimeter by 10 centimeter by 10 centimeter. So what this means? Modular means the brick of size of the brick, which includes mortar, including mortar. Got it? The standard size means this is, let's take an example. This is a brick, right? And this is without including the mortar. But in modular brick, let's say this is the standard brick. So whenever you will place this standard brick in a brick masonry or a wall, obviously, let me change the color, you will get mortar on these sides, right? So that's the reason we have increased 1 centimeter dimension in each side for the modular brick. So now we need to find out the number of bricks, and the brick masonry we got is 1 meter cube. 1 meter cube means we have a wall, right? A wall with dimensions as 1 meter cube, 1 meter height, 1 meter its length, and then 1 meter is its width or breadth. So we need to find out the number of bricks for this wall. So as we know that the total volume is 1 meter cube, and let's convert this one into meter cube. It will be 0.2 meter multiplied by 0.1 meter multiplied by 0.1. This will give us the volume of one brick, right? And we have total volume of 1 meter cube. So what we will do? We will divide 1 meter cube by volume of one brick. What is the volume of one brick? Volume of one brick is 0.2 meter multiplied by 0.1 meter multiplied by 0.1 meter. Divide this and you will get 500, which is the number of bricks required for 1 meter cube of brick masonry. Got it? And the next 2 points are, these are pretty simple points, but very important. What is the validity of use of cement? Obviously whenever you buy cement bag, you will find written on the cement bag, you will find out the manufacturing date on the cement bag, right? After this date, the cement bag is valid till 90 days, or 90 days means 3 months. You can use this cement bag till 90 days after the date of manufacturing. So a cement bag is valid till 3 months. It is 3 months from the manufacturing date. You need to remember this point. And the next point is related to segregation. What is segregation of concrete and why it is caused, right? Segregation means, as we know, that concrete is a combination of coarse aggregate, fine aggregate, and then water and cement, right? To get a good quality of concrete, we need to mix them properly, right? We need to mix them properly, and we need to keep the water cement ratio according to the requirements. But if we don't follow these things, we don't mix it properly and we don't follow the proper water cement ratio, what will happen? These ingredients, fine aggregate, coarse aggregate, and cement, water, they will start to separate from each other, right? So this separation process is known as segregation. So this separation of sand, cement, aggregate in concrete is called segregation of concrete. Got it? What are the reasons? It is caused due to the improper water cement ratio, and other point is that it is caused due to the pouring of concrete above 1.5 meter high. Got it? Let's take an example. Like if you are pouring a plinth beam, right? This is the upper level, and we are pouring concrete from here, right? The distance between the pouring level of concrete to the upper level of this beam should not be more than 1.5 meter high. The unit is 1.5 meter. It should not be greater than 1.5 meter. If it goes above this height, you will face the problem of segregation, right? So these are the causes of segregation. Let's move to the next point. Next point is related to the number of stirrups in a beam. Let's say we have a beam, right? And it is supported on 2 columns, right? And reinforcement is here for this beam. Got it? And obviously there will be stirrups, rings or stirrups in the beam, right? So in this point they are asking us about the number of stirrups. How many stirrups there will be in a beam? We need to find this. So let's say take an example. Let's say the distance between these columns, clear span, this is called clear span. The clear span is, let's say 10 feet, right? So we need to find out the number of stirrups in a beam. So what we will do, the formula is clear span center to center. I will let you know what this means, center to center, divided by spacing plus 1. Spacing means the distance between two stirrups. Let's say the distance between these two is 6 inches, right? So what will be the number of stirrups for this beam? We need to take the clear span, but we need to include it from center to center, center of this column to center of this column. So size of the column, let's take it as an example too. Let's say this is 12 inches, so its half will be 6 inches, and this is also 6 inch, right? So what is going to be the clear span? Total clear span will be 10 plus 6 inches plus 6 inches means 0.5 feet plus 0.5 feet. This will be the total distance divided by spacing between the stirrups is 6 inches, which is 0.5 feet plus 1. Then you will get the answer, which will be 11 divided by 0.5 means 1 multiplied by 2 plus 1, which is equal to 22 plus 1, 23 stirrups. We may need 23 stirrups for a beam having a span of 10 feet. Got it? Next point is, what is the angle of staircase flight? This is also a simple point, but you need to remember this, the range of the angle. Like if we are constructing a staircase, let's say these are our steps, right? And this is the floor, and these are stairs. So the angle between the floor and the staircase should be in between 25 degrees to 40 degrees, means minimum it should be 25 degrees and maximum this angle should be 40 degrees. It should not go above 40 degrees and it should not go below 25 degrees. So the range of the angle of staircase flight is 25 degrees to 40 degrees. Got it? And the next point is, this is also very important point, especially for the site engineers. How much bars should be laid in a bar bending zone? Let me show it to you. As you can see in this image, wherever the bars do overlapping, we call it lapping zone, right? So how much bar should be lapped in a bar bending zone? That means that the 50% of the bar should be at different level from the remaining 50% of the bars. In simple points, you can say that the overlapping of all the bars should not be at the same level, right? Let's say, for example, if you are these 4 bars, we cannot lap all these 4 bars at the same level. If you are lapping these 2 bars at this point, then remaining 2 bars should be lapped at some other level, either above this or either below these 2. So in any case, no more than 50% of the rebar should be lapped to the same level. Got it? It should not be lapped at the same level. If all bars in the columns are overlapped at the same level, what will happen? It will cause column failure. Got it? And other important point you need to note is that in the lapping zone, in this zone, this is the lapping zone, in this zone, the spacing between the stirrups, or rings should be minimal as compared to the regular spacing. As compared to this spacing between the stirrups, the spacing in the lapping zone should be minimal. Got it? So these are two important points you need to remember. One is that it should not be more than 50%. The overlapping in the bending zone or lapping zone should not be more than 50%. And the second important point is that the spacing of the stirrups in the zone of lapping should be minimal as compared to the regular spacing in the stirrup. And next and last point for this video is related to the hook length. What is the minimum hook length of a bar? Which is 90. Let's take an example. This is a hook, right? So the distance from here to here is 40. From this point to this point is 40. So we need to add up this point. First, let's see the distance from here to, if you extend this line, this one is 40, right? This is 4 into dia of bar, and this distance is also 4 into dia of bar. So what remains? We need to take the total distance from here to here, right? We need this distance. This is the hook length. So we know this is 40. This is 40. The remaining distance we need is this one. If we get this distance, then we need to add them all. So what is this distance? This is the dia of the bar, right? That will be 1d. So what will be the total hook length? Hook length will be equal to 4d, this one, plus 1d, then plus 4d. Total hook length will be 9 into dia of bar. And this diameter will always be in millimeters. Got it? So the minimal hook length for a bar will be 9 into dia of the bar. So that's it. Thank you for watching the video. See you guys in the next video. Till then, goodbye.